maintaining the powder and modifying surface conditions. Okay, so this is a insertion all powder. Every kind looks like this. The problem is if the powder the surface is too smooth, the binder cannot catch the powder and bring it through the process into the mold. So everybody should be careful. Before, everybody thinking this one is good, this one is bad. But finally, recently, about 10 years, we modify powder like this one or this one. Okay. So which one is expensive? Which one powder is expensive? Second one. Why?
Because it's shaped.
It's not nature.
Yeah.
It's by process. So every process you will add the money into, and you need to buy raw material and make the powder become the ball. You need to control many parameters. For example, the temperature. For example, the gas pressure. For example, the gas. Because if you want this one is very good shape, you need to use nitrogen or argon for protection during the process. Yeah, if you use air to spray, okay, the problem is surface will be oxidation. Then oxidation it will change your surface condition like a rough, no smooth. So this one much expensive. Same material, so this one is much expensive. This one is inferior, and this one is low. So a lot of people want to use the cheap powder, so they use the modified technology to exchange the surface. So you can see this powder, the surface is like this one after mini or modification technology. So this one should be cheaper than this one, and maybe cheaper than this one. Then they go to the market. Okay. And after century, this one should be keeping same property like this one or this one. So in powder technology, everybody is just thinking about this crisis is powder technology, powder metallurgy. You need to make the material into the powder. This is cost high, right? Because the raw material maybe is broke. But in the other hand, for ceramic and hard metal like the tungsten, like the tungsten carbide, this kind of powder is original, is from chemical way, then get the powder in the rough, so the broke is expensive. But in the other hand, the normal metal like the stainless, like the iron, like the copper, like the titanium, all is done by the block or wire or the other shape is continuous and the bigger block. Then you need to melting again, then spraying. Okay, so powder is from spraying process is now it's normally much cheaper than 10 years ago, maybe 20 years ago. It's now it's very cheap. Okay, but it also is expensive than the broken materials because process free. Okay, everything is process free. It's higher. Okay. So everybody should be remembering how to make the good powder depend on your price, depend on your geometry, shape, surface, and as we just call it 3X. Okay, surface condition and smoothing, the other problem. Okay. today we just discussing the 12 engineering levels. This one is like a game. You need to pass it again. Okay. The levels you need to pass. Why? Because this every process, every technology, not only one thing. This is it's integration, many engineering concepts. So from you learning, okay. Maybe before you are learning material science, and before in university, what kind of subject you use? What kind of major? Okay, so you know the drawing the 2D and the 3D. What kind of 3D program do you use? Drawing. Okay. So you need to know this one, and we need a drawing. Why we need a drawing? When we production, why we need a drawing? In the drawing, the 3D cannot present the dimensions, so we need a 2D by K. So just say, oh, give me the 2D file profile, give me the AutoCAD 2D. Why? Because the 2D can set up the dimension with the polygons. Okay, this is the first one. And you can write down the text on the drawing. Okay, so you can write down the quality requirement in drawing. Everybody can discuss in this drawing, so everybody should decide if the drawing is great, your quality control, your everything you just follow this drawing by standard, by basically. Okay? So everybody should know what technology can develop into the for industry. For any industry, it should be college a lot of know-how and knowledge to it. Okay, so I just separate the 4 topics. The first one is we work on the paper. Okay, everything should be discussion on the paper. But now we know paper. You have no paper, but you just use the computer, the tablet PC, and discussion on the cell phone, everything. So we just can really work on the paper. It means we can discussion in the computer and everything, but not really do the product. Just discussion how to make. So we have a standard name. We call this one. This one is DFM. Please remember, it's very important. Everyone, every student, you graduate from here, you should be know the DFM. This one is design for manufacturing.为了制造手机这么不文雅，来再讲一讲。Okay. English should be good and Chinese also. Okay. 叫做制造可行性分析，这不就很经常吗？或者可制造分析，好吧？可制造设计都可以。好，重点在这里。This DFM is designed for manufacturing. So everything should start from the drawing. Okay. So in the drawing, you can check the material type. You can check the tolerance. You can check the dimension. You can check everything. So it's something. So everybody use the a 2D drawing to define everything. Okay, so we need know these ones here. And for MIM, okay, today the process level is not only for MIM, it's for every technology for production. Okay, but just a step. Because the DFN is starting from a PCB. You know PCB? PCB? You use the computer, you use the 3C product inside as a PCB. PCB, okay. Okay. 电路板 Okay. This from the industry of the PCBA. PCBA is including assembly. What mean? This is not only a board. You need many components inside, including the CPU, including the LCR. Okay. Inductor, resistance, and the capacitor. So you have a lot of material and components, cartridge inside, assembly inside, into it. So if we do this one, never discussion, it is successful or not. Maybe successful, maybe. Not maybe fail, should be fail. We need it again. So in here we will say, okay, what's your T0? Okay, you will listen to T0, T1, T2. For modem or PCBA, the T0, this means the first try. First trial in 0 time. Okay, so from start. Okay, then everybody has many suggestions, many concepts. Everybody put everything inside, then make this PCBA can work. If it work, you can do many things. So you can see, I got a lot of things inside. Okay. When you do the computer, how many components are inside one computer? Like that. Unbelievable. Yeah, it's a very difficult job. But this one is means before you come here, lot of people, maybe it's 10,000, maybe it's 10 million people, just already thinking this one. A version change. Again, improvement. Okay? So, this is a discussion of pre-work on the table. And the physical preparing, this means powder selection and automation and powder validation and inspection. This is physical. Okay. So, Professor Tim just asked me, Dr. Gill, may I have an idea? In the future, we have a classes for MIM, real classes to do the product. I say it's okay. So now Tim is got a injection machine, and your senior classmate has a missing machine. Maybe next time James will tomorrow James will meet you. Maybe it will just bring you to watch the missing machine. So we can do really product. So maybe everybody can discussion and we design a part like the NTUSD logo and we do something we make it one model, then to make a mold, make the MI parts, make the feedstock, we choose 31 CCl or 74 pH material, then injection molding, dividing, and sinter. Okay, I hope this one can do, everybody can join, but it's a difficult job. Yeah, the first time you were thinking, oh, this is very dirty. Yeah, yes, right. Yeah, because everything should be good. James is a PhD degree. You see, it's 5 grade. Okay, so just only 1 year, you have a chance go together. Okay. So the third is for molding and heating, dividing system process, and last one is the support system and the post-treatment. Oh my God. Not finish is okay. Same, the 3D printing also is like this one. Everybody just thinking about, you're thinking what you can do. This is 3D printing just told you, hey, come on, let's do the mold. Okay, so team to buy the machine and make it a lot of money for system support, and we just printing the parts. Then you will find the parts cannot use. Why? Because no post-treatment. So post-treatment is very important. Just like your cell phone or your computer, your tablet PC. You know, finally, one cell phone just use the glue to fix, and the AB device should be into the jig. Okay, jig is a tooling. Jig is a kind of tooling. Tools of tooling. Okay, so let me try. Okay, what is a jig in Chinese? Do you know? Okay, so remember, jig. Okay, jig is special purpose for special purpose tools. Okay, for example, our cell phone or something, we need a screen. Every 3C print, 3C device with a screen. Okay, how to connect with your device? It's glue, it's mounting glue. No screw. If any screw inside the glasses will broken. So how to make this one? Just okay, like your shield. Your shield is meaning glue bonding everything together. Okay, but if this one sometimes can swing, yeah, but this one cannot. So just use the glue bonding. So the glue bonding should use a chip fixed together and over 12 hours, maybe 24 hours. Even iPhone, even Google phone, every phone, any notebook should be use a chip to fix. So when you drop down your cell phone, you are broken or something, it's normal. Yeah, because this one is a dangerous device. We can improve it. Why? Because the glass cannot use a screw to fix. Okay, you can turn back the outside and turn back the backside. Many screws inside. You will say, hey, that's cute. I saw the iPhone, just no any screw. No, we just found it. Then use to disassemble it. You know, the iFixit. Open the computer, open the cell phone. iFixit. Okay, check this website. And any new Easter cell phone in the first day, it will disassemble it. Okay, because it is a way of just do this job, disassemble and to check everything and very quickly. Then everybody know what is version, CPU or something, what kind of chemical they use, what kind of electrical component they use. So I will, okay, try to open this one. Okay. So we just coming to the today classes. Well, I'm sorry because the time is too urgent, so I have no time to translate English. Just many Chinese. So everybody will happy. Just you too. It's after here. Sorry. Okay. This is James. Dr. James. Another really Dr. James is Master James. Okay. And just talking about the MIM. We are in some one company of our consultant list. Okay. We just discussing this one. Okay. Okay, today we're just talking about 12 levels for meta intentional. Okay. The first starting is the source is from the Archimedes. Okay, this means the density equations. So the equation one is this one. Okay, F is this is浮力什么浮起来的浮力的话 Flamboyance is equation like this one. Okay, so it's rho and G and V. V is volume. Okay, N is material mass. Okay, so this one is rho equal the mass over the volume. This one is basically. Well, everything starts here. Why? Because in the history we can know this guy, the king of the Archimedes, just say, I'm thinking about somebody stolen my gold. Yeah, because he used he said he want to like a corona. Okay, then the maker just say okay. Give me the 20 kilogram gold for me. Okay. But after doing this one, just 20 kilogram, the king just thinking somebody will steal my gold. So how to check this one? So the Archimedes is a consultant for the king. So he just say, hey, come on. Tell me what kind of way can explain this one. So it's just thinking about, and just about 1 week, no solution. Okay, so one day go to the bathroom and take a shower. No, sorry, not a shower, take a bath. And just into the water, then water go outside. And you just say, oh, I think this one can use the water change the mass volume. Okay, so in China also has this people call this one is 曹植称象曹冲称象，曹操的儿子哦，后来被杀掉。那个他的曹冲跟他的弟弟叫曹植，被他大哥杀掉，然后被杀之前就叫做煮豆丸豆萁，有没有？把豆子在烧的时候用它的壳去烧。Okay, we're just talking about the stove. Okay, so you go into the water, then you find some water go outside. So different materials inside, the water outside is different. So they can check the volume. Yeah, because it's easy to know the mass, but not easy to know the volume. We just use the water, but something input water. And the water will overflow, go out, then we can use this one to count the volume. Okay, So this one is density equations. So this one is very important influencing us. Okay. So I just leave a paper for everybody. Okay. Everybody can check this document. Okay, this magazine is PIM International. Powder PIM International is Powder Injection Molding International. This is just only magazine. Okay, so it's no paper, just for making everybody discussion and quickly to talking about. Okay, so we just check the. This. Okay. Okay, with me. Okay, I write this one paper and share to everyone because from 1997, the MIM from 1972, the MIM is born in America. Okay, the Raymond, Professor Raymond just applied patent. Okay, the first patent in 1972. Okay, nobody to discussion this equation how to use. Just talking about. Okay, so everybody can download this paper. No problem. I can show you. Okay, after this class, I share to Tim, and Tim share to everybody. Okay, this mechanism is very important for industry. Yeah, because it's easier, not really paper. Just only making article with just a discussion and use the simple way to understand everything. So you can check this one to know the many knowledge and many market information inside. Okay. So MIM can do a lot of switching parts. For example, this one is real cover of the camera. Okay, everybody know. Setup phone is integration electrical device of us. Okay. Okay. Before your home, you have a phone, but just fixed. So you can we say the telephone, but cannot move it. But this one moving, then we added a camera, we added a radio, we added a recorder of the voice, the recorder of the camera or something. So this one is integration, many kind. When you want to calculation something, this one is a calculator. Yeah, you can call it. You can call it calculator. Then you can turn sine. Can make a sine, cosine, sine, tangent, something. So this one is device is very important for your life. Okay. When we was children, we just go outside, needed to call you. And we need the money. Yeah. But now you use Apple Pay. Yeah. Apple Pay. Do you use Apple Pay? Yes. Okay. Why? Because it's easy. But when you use Apple Pay, your money will lose very quickly. Right? Because there's no feeling. Yeah. Money has the weight. But Apple Pay no weight. It's just money is gone. Okay. Then in China, in everywhere. So a lot of mechanical part metal is doing for support this cell phone stronger and long time for use and no damage. So we change it metal inside. So that is a lot of one. Very interesting is camera. Before the camera is separate. Am I right? When you are children, your father is use a camera to take picture and then go to the picture shop to print this one and pay a lot of money. Yes, when you fail, you will say, haha, This is a field, just one field about 36 piece. Sometimes it's fail, okay, this one is gone. But now, when you take picture, it's no good for watch, okay, well, erase, easy. Okay, so this one is a camera rig with protection for camera. Why camera only one lens? Why now it's a lot of lens? Why? Do you know? Do you know why? The camera many lens in your side, a lot of lens. Why? Long time ago, the camera cannot scan. Oh, so your camera can scan, your cell phone can scan. Yeah, why? Because there's a different lens, we just separate. Okay, maybe in iPhone, this one is for VGA, for color. This one is for scan, to scan everything. And this one maybe is for the sharp image, should be sharp image. So we have 3, maybe 4. In China, they have 9. Names 9. My God, what kind of 9? You say the 1 of 1, 1 of 1, 1 of 2, 1 of 3. Okay, many function integration inside. Okay, so anyway, the lens is expensive. We need a protection. So we don't protection. So we need just use the metal to make this one. And this one is metal button. Okay, button. Before we just use the plastic button, and long time ago it was broken, but we changed it to metal. It's not broken. Okay, so you just say, oh, okay, this is metal. Okay, this one is for SIM card, SIM tray. Okay, so MI can do a lot of interesting mechanical parts. Okay, so this one just a discussion in the 2D side. This one is only the after injection, we call this one green part. And after sintering, very interesting is in MIN, after sintering, the shrinkage is uniform. Is it real? Heading is real? In your mind, it's real? Impossible. Yeah, impossible. But how much tolerance you can approach? So we need to know. So ever since during the MIN process, 30 years before, it's very wrong, not easy to correct. So we just do material set, okay, material set, or we call this one is steel set. In casting, iron casting, just steel set. Means we just make this one is big, then machine approach the correct dimension. Okay, but MIN means we want to set the post machining process because it's fun. Right? Yeah, everything is to do what? Maybe because Dr. Q is a factory manager. Just say, hey, Dr. Q, please check the parts for me. I say, when I watch 1 minute, 1 minute is how much money spent, you know. So please require yourself and do the good solution. So this means every process, every more process, the price will be higher and higher and higher. Okay, so it should be understand. Okay, so we hope use a kind of material missing way. Later the materials can simply be uniform. Okay, so we use this equation to check the before and the after. Okay, so this one is green parts before. This one is center part is after. Then we just call the SS of the SG. Okay, so we have different. So then we can make the equation. Here. The question is M and Boolean. Okay, this is summation M. It means a lot of materials are inside together. We just separate this mass, and we can separate Boolean because we have density information. So this one is normally, but we know in the data sheet of the materials, okay, we say it's MSDS. Oh, we say the merely in English, you just can check. Please check the MSDS. What's the MSDS? Okay, everyone check MSDS. Okay, by your cell phone. Okay, maybe the team will list this one for examination for you. Okay, understand? So when you have the MSDS from the vendor will give you this one, this standards for you. Then you can check the density. You can check the material properties inside. Okay, maybe just so you know, we don't believe the MSDS because this is a standard. Please give me a mirror sheet. Mirror sheet, this means data sheet from your production line. For example, I'm a vendor. I sell this material. I need to take the mirror sheet for you. This including the materials, chemical composition, including the physical property information. For example, the weight. For example, the density. For example, the tensile stress, elastic strength, something. Okay. So this is very important. Then we have got this one row, and we know the materials, so the mass, so we can know the volume. This is very easy. Okay, so this one is what to define the OSF. OSF means this one is XX close this one OSF equal the X. Oh, okay. So the C and the S, what is the CS? Okay, S is center part after sintering. Okay, so this one is the center part. Okay, the C is the cavity, is a molten cavity. So this means we take a drawing. Take a drawing is a final product. Final product is means this one, center part. Okay, so center part. So we just use the drawing, close the OSF, we can make a tooling. Okay, so this one, please, everybody to read this articles. Okay. Not very difficult, just easy that you can understand. Okay, so I write down here. Then here is assumption is volume is x equal to y equal to 0. So you can make it an easy calculation. Okay. So in finally we have a lot of OSF to define. We just define solid volume compared with the binder volume. Okay, but with the high temperature, the binder will burn up. So and finally it's 0. So this means we just don't thinking about this one. We just use this one compared with this one and make it OSF. Okay. So sounds like so, for example, this one, we also use this one. Okay. So, volume C is cavity. 10. Why? It's divide. Okay. 10. Okay. Okay. Then this one is okay. Then the pass. The pass is okay. It's okay. Then please. How much? Somebody can give a share for me. Then show you iPhone LV。好了，算一下，都给到你。8.434. Okay, just 3. Okay. Then what is OSF? OSF is very. This one always in up. So it's 10. How much? Okay, to 5. Okay. Eight to 5. Okay. 你算多少？啊？8.58啊，是 OK。所以 this one is 8.58，585正，582好来。Okay, you make mistake. Okay, here.看多少？Okay. This center is very important. And the BASF, a German company, German chemical company, is a developer this technology and define. This is a limitation for MIM. 30 years ago, they defined this one. This bullet is just the powder loading. We call this one just powder loading. Okay, powder loading if approaching 63.2%. Okay, the MIM pass can approach the perfect shrinkage rate. Okay, so this one is defined by BASF. But now we can do this one to this one normal, depending on the powder size. Okay, okay. Remember? Just my classes. MIM OSF is successful. The key point is the powder should be on what kind size, what kind micros. Remember? 13, 14? Which one? Remember? Okay, please everybody remember 13 micros. Lower than 13 micros, this equation will be approached to perfect. Okay, 13 micron. Okay. How about your hair? Diameter. So next time I bring labels, then pitch one, then I guess your hair about 120 micron. Maybe. Oh, so please understand how much. Okay. Normally the man hair of the man is 90 to 120 microns. A girl maybe is
17 to 18, so it's a more fine. But different people, different hair. If you find somebody use a spring hair, okay, maybe it's a different size. It's not really circle. It's like a side is longer and a side is wider. Okay, so different. Okay, so this one should be everybody remember. This OSF equation is very easy to use. Okay, just this one is under the chain, and this one should be smaller than in the bottom side. Then maybe this one you can do calculations. Okay. So this one is this in England magazine. Everybody just write down an email to me. Why this one can use the very true? I just say, please, everything when you discuss it, please do it by yourself and to check everything. Okay, just do by your hands. Not just only watch. You should do. So team just discussion with me. Maybe next classes is operation in the lab. Okay, this one I think is good for everyone. Should be because this one how the technology very important for you. Yeah, because this one can do many kind of products. For example, now Dr. Q is for cosmetic or for the woman. Okay, cosmetic, makeup industry. Oh my God, the makeup industry. Before I just say use the cell phone, but cell phone is a fashion product. You know the fashion product. This means this year everybody just want to buy iPhone 15, but when iPhone 16 come in, you will give them up. Yeah, next year, oh, I need a new one. This is a fashion product. Fashion product only 1 year to 2 years life. Then you will forget about it. But a longer product is longer order than the fashion order. Fashion order means very quickly. The lifetime is short. But a longer products, for example, your car, your glasses or something, you will do about over the 10 years or something. The key parts, you will again when you for example the battery, for example the washer, for example the spring something, you can exchange the standard parts. Then again to do. For women makeup industry, very important is the lips can do again because maybe the color, maybe the shape is good for women. So this is different. Not only fashion and we need a long time. So we need a reliability higher than the 3G components. Okay. Okay. So please everybody to check this one, then you can understand technology key technology here. Okay, just the equations. Okay, then we make the Excel table. Then calculation the binder. Why? Because this is a 17 pH is an error. We needed to treatment the error, not easy to do the binder. We just separate the binder name and separate. This is our design. Just totally is 100. Then we just calculation. Finally, is each one the weight. Okay. For example, this one is our powder is 15 kilos. Okay, this is 15 kilos. Then how much weight of binder in here? Then each one in here. So totally is depend on this equation to calculation. Okay. So please everybody just check this English version. And if you have time, just can check this magazine with a lot of information inside. So please, from 2012, I just write down the paper to English PIM International, and the owner just said, okay, but please write down a lot of NCR information for us, marketing information. And finally, I make this one. He just say, because I never know you can write down the technical paper. I say I am technical people also, so I just make another paper. Please, if you want, you just say check Dr. Q inside. Okay. Just go into the page, and then you write down the Dr. Q. Okay, this is the check inside. I wrote down the paper inside. Okay. Okay, anyway, mathematically is basically for your life, for your engineering life. Okay, if you want to become an engineer, please, mathematically is very important. Just one and one is easy, not very difficult. Okay, so. Then I just list different particle size. Okay, this is particle size by my hands. Okay, so different particle size make decision your process, your technology. Okay, for example, this one is PN. PN is about 70 to 160. Okay, it's one range. Okay, this is we say this one is PM. PM. Okay, this is a place and the center. So you just remember the beginning of the classes. We just watch the video PM. It's a raw powder with the easy process, but not really easy because even the one up or one down. Now the top technology is 3 up and 5 down. They can make many steps. Okay, difficult parts, the shape is difficult. So not really simple, but just PM is also cannot approach it very strange shape. That's only the step and the 2D animations. Okay, so they use raw powder. Why? Because they need the powder very easy to flow. But easy to flow. Yeah, because the raw powder can flow very easy and can automatically freely, no use pressure or something, just flow down. Okay, so this one is raw powder. And the second is DED, is for 3D printing is DED, the rate of energy deposition, metal additive. Okay, also it's 3D printing for metal. Okay, then this one is PBFEB. This means hot bed fusion by electrical beam for MAN. Also it's a 3D printing process. They have 3D printed classes in the course of medical device. 好的，研究生，这个研究生嘛，用那个这门课没有讲到那个3D 3D 有之前有学的一样的。OK。So if you have interest in MAN, I have a book. Okay, and also copy to team. Everybody can share. The first book I recommend is this one. Handbook of MI. This book, electrical version. Handbook is of manual injection molding. Okay, it's a WP from WP. But this one is a partial conjugate. Not only, I'm sorry, not a very one line to thinking. Just a lot of ascension. So we just discussing this one. Okay, it's a content, okay, a lot of things. So I separate it and the translation into the Chinese. So the Chinese student is very happy. Okay, you are also can watch the English one, but I also hope you can understand. So here's every chapter just separate. Then everybody can check this one. Okay, if you are interested, I will maybe team them, professional team. Okay, the other books I think is about NT. This one is also can download the English version. Additive manufacturing technologies. Okay, this book is very fast and very clear. Everyone can read and compare the environment. But this one should explain a lot of time. And the professional professional is a professional in Taiwan, the top one. So Dr. James, your senior classmate also is a reader this one. Okay. Lucky is because of the coronavirus 19, I have time to translate in Chinese. So every Taiwan student will happy. Yeah, we just can check the Chinese. But also you can know a lot of page. Okay, and it's update twice. So I think this one is good. So everybody, if you're interested, please just connect with team and he will share to you. Everybody should understand English and then translate it into Chinese. I need to spend about a lot of time to check the translator means because sometimes it's different. So it's something is difficult to understand. Okay, this is very short. So this a lot of things is just talking about metal additive manufacturing, not magic, no magic. You need to spend a lot of time and read and to understand. And then finally, why in your life, normal life, no 3D printer parts inside. Why? Because very expensive. They can do the more, they can do something, but they cannot do the real industrial product for normal life. Why? Because production speed, production cycle time is longer, and the materials is expensive. So many limitations for the process. So please don't read the news and read the website. Oh, the 3D printing is the future top technology. No, it's a joke. When you do everything, you can understand. Oh my God, a lot of problem to make solution. But human is very hard to develop MAM. So basically, for metal additive manufacturing, all is based on powder. 80% on powder, so you need to know powder science, very important. Okay? So I have two focus recommend to everybody. Okay, now it's 2:30. We just working 15 minutes. Okay, 2:45 minutes. Okay.